this is going to be my running of my heap implementation. So what actually happens here is we're going to have our two exceptions, the heap full and the heap empty. Heap empty is going to be if it's empty, full is going to be if it's full. The variables are going to be array, be an array list, which is going to contain the heap. It's going to be the heap array, capacity, and size. You told us that we need to have the size be a power of 2. I googled why that was and tried to read around why that was, and it's because it's considered efficient for the memory. So the heap array, the size of it is going to be the capacity of the heap itself, so the available space that we have. That's if we just create it based off of size. If we create it based off array list, it's simply going to provide us with the same mathematical up here. And we're going to set the capacity again, but we're going to force all the objects that we provided in the array list into our array list, the heap array, via a for each loop. So how do we do an add? First we do a check, see if it's already full. If it's not full, we're going to add the item to the end of the heap array, then we're going to increase the size. We're going to calculate the indices of the current node and its parents by doing size minus 1 to find the current index, because we're going to be at the end. And then to find the parent index, we're going to basically do the current index minus 1 divided by 2, giving us the middle. We're going to do a compare using bubble up, and we're going to make sure that the current index is greater than 0 in the heap array. We're going to get the current index, so that's going to be an AND statement, and then we're going to get the current index. We're going to get the object in the current index of what we're trying to add, and then we're going to compare it to the heap array, get the parent index, which is the middle, and make sure that it's over 0. If it's over 0, that means current index is going to be bigger than the parent index, which means that we need to do a swap, and we'll continue to do that each time. One moment. And we'll continue to do that each time, because we're going to swap the current node with the parent, flip it, and then we're going to move up the heap, and then we're going to set the current as the parent, and then we're going to generate a new parent as halving it again. Then we're going to continue to go through this for this while loop until we meet the specific standard that it's not going to be bigger, so we found its place within the heap. Removing, once again checking if it's empty. Up here is checking if it's full, down here we're checking if it's empty. We're going to store the item to be removed, aka the root. We're going to replace the root with the last element in the heap, so we're going to do size minus 1 to get the end. Then we're going to set it. We're going to remove the last element from the array because we can't have that in there since we already replaced a item within it, an item that we were hoping to remove with the last object. So we remove the last object, de-increment the size. We're going to set the current index to 0 so we can use the heap, so we can do the heap processing. Then we're going to check the left child and the right child. We're properly going to process those by doing 2 times current index. So 2 times 0 is going to be 0 plus 1. Then the right child is going to be 2 times current index plus 2, which is going to be 2. So we're going to have index 1 and index 2 in this case. And then we're going to make sure that the child is not out of bounds. Then we're going to determine the index of the maximum child via int max index left child index. We're going to call, so that will give us 1. Then we're going to make sure that the right index is less than the size, so we don't go out of bounds. Then we're going to make sure that the heap.get right child, which is going to be 2, compared to the left child, is greater than 1, so we know that we in fact can't find the maximum, the index of the maximum child. So we're going to just search for the maximum value. Well, not value. Hold up one moment. We're going to search for the We're going to search for the maximum item that we inputted. One moment. Once we do that, we are going to see if the current node is less than or equal. I mean, is less than the maximum child. If it is, we're going to swap it. So we're basically doing what we did above by up in the add statement. We're basically doing what we did up here by by maintaining the heap's property. So what we're going to do is we're going to set the current temp index to the current index that we have, which is going to be 1 at this time. Then we're going to set the current index heap array to the max index. We're going to set the max index to temp. If the node is less than the maximum child, we're going to update it, the current index to be the max index to do the heapify process. Else, we're going to break the loop. We're going to return the removed item as we stated up here, returning T. Next is a simple boolean for if an object, if the heap's going to be empty, size equals 0, yeah, it's going to be empty. Full, size equals capacity, we're full. Size returns size. Peaking, we're just going to get the first index of our heap. ToString, we're going to use string builder because it's more efficient. I was reading up on that. String builder, we're just going to append, and we're going to use a for loop for. We're going to use a for loop. So if it's 0, we're going to have 0 plus 1, which is object 1. And we're going to append string, which is going to be a divider. We're going to append the heap array, get the object 1, and then we're going to create a space, and then just keep on looping through. And here's a simple test. We're going to run our simple test, show that it is actively working, and you can see here that we are working. I want to thank you for taking the time to take a look at my video, and I hope you have a great day.